All right, this is Honors Pre-Calculus, and we are reviewing for a quiz that is on sections 1.4, 1.5, and 1.6. On the module, I posted a review with what you need to know, and I wanted to go over a few questions that I've been receiving a lot of emails about. The assignment that we had on 1.6 that was in the book, a lot of people were having trouble because they were following a specific order where the questions in the book weren't necessarily going by a specific order. So what I did is I made some questions on the review that tells you specifically that we are going to have an order that you must follow. So the ones that you were having trouble with on the assignment, they didn't have this order. And it'd be more helpful if I had one of those up. So I'm going to go grab one of those really fast. Dashboard, pre-calc. Let's go to modules. And it was last week. So there were some questions, like I know question 42 was one that a lot of people were asking me about. There were more, but I know 42 was a big one. Okay, so the number 42 says the shape, and I'm just going to use my snipping tool and just put it into, and put that into Cami so I can write on it. Actually, I can just probably write on it with the snipping tool right here. Okay, so this is saying that the shape of it is that x cubed shape. It's got that x cubed shape, but we have to move it 6 units to the left, 6 units downward, and it has a reflection in the y-axis. So some people were literally taking that step by step, which I understand why you did it. And I feel like the book was not clear enough, and if you did do it step by step, you didn't get the right answer because the book did not make it clear. So that's why I made it more clear in the assignment. So some people were, taking that shape, they were moving it 6 to the left, 6 down, and then once you've moved it 6 to the left, 6 down, when you reflect it in the y-axis, sorry, it was ugly, when you reflect it in the y-axis, it ends up being over here. And they were telling me the equation for this. But that's not really what they were trying to ask. They were asking more like, it's moved over here, but it has the reflection, so it's facing down. And I do think that that was super confusing, which is why we took some time today in class to go over it so that you understood how to write the correct equation. This was x cubed. So we would have a negative, and then we'd have a parenthesis, x plus 6, close parenthesis cubed, and then minus 6. Or if you distributed and you had parenthesis negative x minus 6, cubed minus 6. Both of these will work on number 42 in the assignment. But that's why a lot of you were emailing me and asking me why your answer wasn't correct. So anyway, because that happened, we move on, and now I've given you an assignment that actually will tell you the order to follow. So we shouldn't have as many people missing the questions. So here's just 2 examples that are like the ones in the review. Let G be a function, so right now it's telling you that we're going to name it G, be a function that is translated up 4 units, followed by a vertical stretch by a factor of 3. So this says we have to do the translation up first. So I'm going to take my f of x equation and I'm going to translate it up 4. So we'll have square root of x and then plus 4 on the outside. So it's taking my function, moving it up 4. Now, after that, we're now going to do a vertical stretch by a factor of 3. The vertical stretch has to vertically stretch the entire function. So we're going to take 3 times the entire function. So vertical stretch, normally, let's see, square root of x, just a square root of x right here, vertical stretch would maybe make it look like that. Let me change the color. Since this one was already up 4, and then we stretch it from here, it's making the entire function further away from the x-axis. It's not just stretching from the middle of the function, it's not stretching the two pieces out, it's taking the function and stretching it away from the x-axis. So it's going to have a further translation up than 4. And we'll see that when we distribute here. Our g function will be 3 square root x plus 12. Because the stretch happened after we moved it up, this ended up being way up here at 12 on the, oops, sorry, it was super messy, right there at 12 on the y-axis. So this next one, let g be a function with a horizontal shrink by a factor of a half, followed by a translation left 5 units and down 9 units. So I'm still starting with f of x equals square root of x. And we're going to first do a horizontal shrink. So anything horizontal is going to happen to the x. We're going to replace x. And the reason why I chose 2 is because we have to do the opposite of multiplying by half. We have to multiply by 2. So this here means replace x with parenthesis 2x. That's what this means right here. So in the equation, I'll have square root. I'm going to take out x, and I'm going to replace it with parenthesis 2x. So I get radical 2x, square root 2x. Now I'm going to translate 5 units left and 9 units down. So now to my f of x, I'm going to input a 5 units left. So I'm going to change it to be an x plus 5. And we're also going to take the entire function and not add, sorry, it's minus 9, go down. So we're going to do this. So this means replace x with parenthesis x plus 5. So I'm going to have my final g of x equation. I'm going to have a square root of 2. I'm going to replace x with parenthesis x plus 5, and I'm going to have a minus 9. So I'll have square root 2x plus 10 minus 9. So now if you looked at just this equation here, you could not tell that there was a translation 5 to the left. It has to be after the number in front is factored out, can you see that it's 5 to the left? So this is the transformation form. This is a simplified version of that, but this is usually how we would write equations. Okay, so you'll have a few of those in your assignment. The other thing that we reviewed today was some content from Algebra 2. This was rational expressions in Algebra 2, and we had to review that because what we're learning new involves you knowing how to do operations with rational expressions. So I gave some time in class today to work through these as review, and then of course we had to go over it. So I'm going to go over it now. Anytime we want to add anything in math, like if I want to add x plus y, we can't because they're not like terms. So in order to add anything in math, we have to have like terms or subtract. Adding, subtracting, basically the same thing. So here we do not have like terms. They are both fractions, however, their denominators are not the same. In order to have the denominators the same, we need to look for factors. So I'm going to try this with a much easier question. If I had 1/4 plus 5 over 6, I would look at my denominators, and I would hope that you all would say that the denominator would be 12. But sometimes we need to multiply the 4 and the 6 together, making it 24. Both of these would work, 24 is not the lowest common denominator, which makes it a little bit harder. We have to like simplify at the end. We want to go with the lowest common denominator to add things together. But in order to know that it's 12, you have to factor the 4. 2 times 2, 6 is 2 times 3. They both have a 2 in common, so they both go to 2. And then this one has an extra 2, and this one has an extra 3, which is where I got the 12. So we have to really see what factors first. So I look at number 71, and x does not factor, and 1 minus x does not factor. So what we have to do is we do have to multiply 4 over x and 4 over 1 minus x by the other denominator, but in a value of 1. Now what I mean by a value of 1, x over x equals 1. That's not going to affect the value of this overall expression. It just changes its appearance. We can't change the value. This does not have an equal sign. I can't multiply by anything I want. I'm only allowed to multiply by 1, so it keeps the same value. So I multiply fractions straight across, and I will get 4 multiplied by 1 minus x over x times 1 minus x plus 4 times x over x times 1 minus x. Now we have a common denominator, so since the denominators are the same, I can add the numerators. And I'm going to go ahead and distribute while I add them. 4 minus 4x plus 4x. We look for anything that could simplify, and this does simplify to be 4 over x times 1 minus x. Nothing will factor, so nothing cancels. That's the final simplified answer. Number 72, we look at the two denominators. They are not the same. They're close, but they're not the same. The question you ask yourself is, will x plus 5 factor? Will x plus 5 factor? It does not factor. Will x minus 5 factor? It does not factor. So if it does not factor, we're going to have to multiply by a value of 1 that makes both denominators have the exact same thing. So we're going to basically be multiplying by each other. Okay, so I'm going to simplify that, and I'm going to get 2x minus 5 over x plus 5x minus 5 minus 2x plus 5 over x plus 5x minus 5. So now we have a common denominator. I'm going to go ahead and distribute while I do this. So I've got 2x minus 10 minus 2x minus 10 and x plus 5, x minus 5. I'm going to collect our like terms, and I get negative 20 over x plus 5, x minus 5. Now, you do not have to go further than that, but sometimes people just automatically do it. So if you did multiply the denominator out, you would get, oops, I have a mistake in my denominator. There we go. If you did multiply the denominator out, you would get x squared minus 25. And the reason why I did that just now, I wouldn't do it. The reason why I did it is because I want to talk about canceling. You cannot factor out a 5. You cannot cancel a 5. And I'm seeing this on assessments and assignments where people are canceling 5s. You can't do that. The rule is, can you factor and cancel the factor? Can you factor and cancel the factor? So going from here just backwards, if I factor the denominator, it is x plus 5, x minus 5. Neither of those is just a 5. You cannot factor just a 5, so I have nothing to cancel with the top. It's only when you can cancel, it's only when you can factor that you can cancel factors. So that would be my final answer. Okay, the next two are they're really similar to these two, so I'm not going to go all the way through them, but I did want to talk about 73 for just a moment. 73 does have a common factor. So really the only thing we need to do for 73 is multiply the top and the bottom of the first fraction by x. So we would have 3x minus 2 over x times x minus 1, and that would be it for that question. All right, next page, 75. Oops, 75. This is multiply. We multiply fractions straight across, but this is not currently a fraction, so I'm going to make it into a fraction. We go straight across, and we will have x minus 4 over square root x squared minus 4. Now, first of all, the 4's will not cancel because one is under a radical and one of them is not. Same thing with the x's. You can't cancel it because I can't factor out a 4 from the numerator. Lots of reasons why we can't cancel here. Another thing is I cannot square root the x and square root the 4. What I brought up in class today was if I had 3 squared plus 4 squared equals 5 squared, and I took the square root of both sides, I would get 5. Here, I would not get 3 plus 4. You cannot square root separate terms. You square root the entire thing. So you cannot square root x squared minus 4. So that's where I got. But I learned this rule that says we're not allowed to leave a radical in the denominator, so we can rationalize it. This is just a simplifying rule, and the directions were to simplify. So on top I'll have an x minus 4 times x squared minus 4, and then on the bottom I will have x squared minus 4. Again, I cannot cancel the 4's or the x's because I cannot factor out a 4. And the entire factor itself is not the same as this entire factor. I also had to put parentheses because if I didn't, then it would only be the 4 being multiplied, but it's the entire quantity being multiplied. So that's it. Number 76. Let's see, x over, I'm going to go ahead and factor this as I'm writing it down, x plus 2x minus 2. And we're multiplying that by x minus 2 times x plus 1 over x squared. We multiply straight across, so just make that line go all the way across. And then if it is factored, I just factored everything. There's only multiplication between each of the parentheses. I can cancel. So I canceled out an x, I canceled out an x minus 2, and I have x plus 1 over x times x plus 2. And remember, we check for domain restrictions. Let's see, x cannot equal positive 2. So we do have to add that extra domain restriction in there. All right, 77, just going to go a little, just go higher with 77. We'll go this way. Something to factor. I'll go ahead and factor that first. X plus 3, x minus 3. And then we're going to divide that by x plus 3 over 5. So when we divide, we actually don't divide. We multiply by its reciprocal. So I've got x plus 3 times x minus 3, multiply by the reciprocal, 5 over x plus 3. When I multiply, I put this over 1, I go straight across, and after I've multiplied, I can cancel. So I get 5 times x minus 3. And we look for any domain restrictions, And right here we canceled out that x plus 3, so we'll have a domain restriction of x cannot equal negative 3. Number 78. You can go ahead and factor it while I'm copying it. X minus 7, x plus 4, divided by x times x plus 3 over x plus 4, x plus 1. Okay, we cannot divide, so we have to multiply by the reciprocal. So the first fraction stays the same. We're going to change it to multiplication and reciprocate. And then I'm going to multiply straight across. So here we go. Multiply straight across. Excellent. Now it's multiplied straight across. Everything's already factored. So now I can cancel out some of the common factors. The x plus 4's cancel, and that's it. So now I have an answer of x plus 1 over x minus 7, x plus 3. Now the domain restrictions are that x cannot equal negative 4, and that comes from canceling out the negative 4 here. It cannot equal negative 1. And the negative 1 comes from originally negative 1 would have been a domain restriction in a denominator. It just happened to flip in the next step, but it was originally in a denominator. And then finally a 0 because we canceled that one out. So when you do division, you just want to kind of look at the step before you flip it to see if there's any domain restrictions after you flipped it. So that would be the answer for that one. Okay, my next video we will do the actual notes for 1-7.